So for number 1, I'm subtracting these two fractions. All right. In a lot of classes today, the first step they've wanted to do is make it improper. I love that because improper fractions do make math easier. If we're multiplying or dividing, it has to be improper 100%. For adding and subtracting, sometimes making it improper makes our numbers a lot bigger and harder to work with. On number 1, if I look at the top, do y'all see how it says 1 minus 7? Can I do 1 minus 7? No, I can't take 1 and take 7 away from it. And 1 and 7 are really far apart. So when I look at that 1 minus 7, I know I'm going to have to get the denominators to match. But these are so far apart, they're probably still not going to be able to subtract. So in this case, I am going to go ahead and change that fraction to improper. So that's where we do that backward C. We'll shut the door. All right, so we're going to multiply our big number times the bottom. So 2 times 9 gives me 18 plus the 1, 19. So I end up with 19 over 9 minus, and that 7 over 6 was fine the way it was because there was no whole number. All right, now when I look at this, can I subtract that now? So now, I could obviously do 19 minus 7, but can I subtract those fractions the way they are? What are y'all thoughts? What do you think, Malachi? They have to have the same denominator. So no, we cannot subtract these. So when I look at 9 and 6, now remember, I want my denominator to be as small as possible because the smaller the number, the easier the math. For 9 and 6, what's the smallest number I could multiply and both of those equal? Juliana? 18. Because 9 times 2 is 18. If I do it to the bottom, you notice I did it to top as well. And 6 times 3 is 18. If I do it to the bottom, do it to the top. So what are my new fractions going to say when I multiply that? What are my new fractions going to say? Malachi?
36.
Okay. 38. Mm-hmm. Okay, and? 38 over 18 minus 21 over 18. Now 38 and 21, I can probably subtract those in my head because we don't have to do any borrowing. What do I get when I subtract those, Ansley? $17 over 18. Guys, make sure you're working along with me because we are not volunteering super well, so I'm going to just start calling on y'all. So we get 17 over 18. All right, and that won't simplify. That one's done. Okay. All right, let's look at number 2. So number 2 doesn't have any mixed numbers, so we should be good. What's a good denominator for these two, Braden? 12. Guys, you notice 3 and 4, like if I'm counting, it's 1, 2, 3, 4. They're back to back. If they're back to back, the only thing you can do is take the denominators and multiply them times each other. All right, when they're back to back like that. Okay? So, Braden, when I multiply that, what's my new problem going to say?
8 over 12 plus 6 over 12.
Very good. Okay. So when I add those up, what am I going to get, Frank? We're adding, not subtracting. 14 over 12. And Frank, is that a good fraction to leave? No. What can I do to it? Make it a mixed number. So how many times will 12 go into 14? Once, with how many left over? 2. So I get 1 and 2 twelfths. All right. Aiden, is that a good fraction? Okay, looks good. Looks like a good mixed number. Jordan, what do you think? It can simplify. So guys, that's the biggest thing on fractions is we do all this work, we get an answer, our answer looks good, we're like, yes! But remember, we always have to double check that simplifying. What number can go into 2 and into 12, Jordan? 2. So 2 divided by 2 gives me a 1 on top, and 12 divided by 2 gives me 6. So we do have to simplify that every single time if it will. Alright. Next one. What do you notice about that first fraction on number 3? What do you notice, Braden?
It's improper.
It's improper. So I probably need to make the other one improper. Alright, so I'm going to leave that 32 over 6 the way it is. Minus 4 times 7. 28 plus 5. 33 over 7. So, and you'll notice, guys, 32 minus 33. Can I actually do that subtraction right now? 32 minus 33? No. Not only do the denominators not match, but 32 is smaller. When we do that denominator, get a common denominator, it's going to fix that because 32 and 33 are pretty close together, aren't they? All right. What's a good denominator for 6 and 7? A good denominator for 6 and 7. What do you think, Alan? So what do we get? When I do that multiplication, like what do you get as your denominator? Yeah, so we want to use 42 for the denominator, like he said, taking the 7 and multiplying, and then taking the 6 and multiplying the other fraction. Because again, 6 and 7 are back to back, right? So the smallest thing possible is just them together. Alright, so now guys, these numbers are going to get a little big. That's okay, we can handle it. 32 times 7. We might have to do that out to the side. What do I get when I multiply 32 times 7? Maggie? 224. And that was over 42. Minus, what do I get when I do 6 times 33 or 33 times 6? Bailey? When we do 33 times 6, what do we get? 198. Very good. Oh, trust me, a lot of our 9s and 4s look pretty close. Make sure we're always leaving those 4s with an open part on the top, because my 4s that close up do look like 9s. Alright, so now what do I need to do? I gotta subtract. Now 224 minus 98, that's kind of big. So if I wanted to go over to the side, I could do 224 minus 198. Okay. Can I do 4 minus 8? No. So I'm going to borrow. This is a good little review on borrowing. So 2 becomes 1. 4 becomes 14. 14 minus 8. 6. 1 minus 9. I need to borrow again. So 2 becomes 1. Remember, I just put the 1 in front. I see a lot of people, for some reason, want to put a 0 there. Remember, when I'm taking 1 away, I can only put a 1 with the number that was next to it. So now it's 11 minus 9, which is 2, and 1 minus 1 goes away, 0. So my answer on top ends up being 26 over 42. Aiden, is that a good answer? Okay, remember, what do we always got to check for? Simplify. Can 26 and 42 simplify? Yeah, what number can go into this? 2. Remember, these end in even numbers. So guys, and I know a lot of 26 and 42, it's really tempting to try to pick a bigger number than 2. But if you can look at it and you know 2 works, which makes more sense? Staring at this for 5 minutes trying to do a big number, or just dividing it real fast and then seeing if I can do it again? Yeah, let's just divide it real fast, see if it'll do it again. So 2 will go into 26. What do we get there? 13. And then 2 will go into 42. What do we get there? 21. So will that simplify anymore? No, so if I had stared at this for 5 minutes trying to find a bigger number, it would have been a complete waste of time. Because my answer, all I can do is use 2. Okay. All right, number 4, we have an improper fraction, but we have 2 improper fractions, so it's already done for us. So now what do I need to do, Rebecca? Okay, what are we going to multiply by? 3. What number do I want to get on the bottom? What's a good number that 9 and 2 can both match with? 18. So 9 times 2 is what's going to give me 18. And then 2 times 9 is what will give me the 18. So we're just kind of switching those to multiply. Right? So what's my first fraction going to be here? Harper? (46/18), yes. Plus, what do we get for the other one? Harper? Plus 45/18. All right, and when I add those together, what do I get? 46 plus 45. Maggie?
91.
91 over 18, which obviously is improper. So we know we're going to have to figure something out to go with this. Thoughts? What do I need to do? Maggie, what do you think?
Divide.
We got to divide. So I can do some long division. So I can put 18 here, divided by 91. And we got to decide how many times can 18 go into 91? How many times do you think 18 will go into 91, Layla? You can just pick a number to start with. 5, okay? So, and I like, guys, 5 is an excellent number to start with because 5 is kind of right in the middle, right? And then once I use 5, I can decide, okay, is it good? Or should I go higher or lower? 5 is a great starting number, Layla. So I'm going to kind of go over here to the side, and I'm going to do 18 times 5. Mainly because, remember, I don't know if it's going to work, and I'm writing in pen, not a pencil, so I can't erase. So 5 times 8 is 40. Carry the 4. 5 times 1? 5 plus the 4, 9. So I get 90. Is 5 a good one to use? Yeah, it's really, really close, and it's definitely smaller. So I'm going to do 5, and then 5 times 18 we just found out was 90. So what do I have left over? 1. So 18 went in 5 times, and I have 1 left over. So how do I want to write that fraction? Malachi? 5 and 1/18. Perfect. Excellent job. Okay. All right, let's look at number 5. Ooh, sorry, thank you. All right, so you'll notice on number 5, I have 2 mixed numbers, right? But guys, if I look at the fraction, can I do 2 minus 1? Can I do 2 minus 1? The denominators don't match, but I could subtract those fairly easily, correct? If I needed to. So guys, because I know I can do the math the way it is, except for the fact that the fraction rule is not working yet, I'm going to try to do this problem without a mixed number. Remember, mixed numbers make my numbers bigger. Do y'all agree? So if I can do this, keeping my numbers small, it's going to make it easier. All right? So let's I'm not going to worry about the whole numbers right now. If I end up with something funky happening, okay, that means I needed to go back and do the mixed stuff. All right? But let's try to do it without a mixed number. What's a good denominator for these? Maggie?
35.
35. So multiply the first one by 5, the second one by 7. So I'm going to keep the 4 there. 2 times 5 is 10. 7 times 5 is 35. Minus, keep the 2 there. 1 times 7 is 7 over 35. All right? So guys, now if I look at those fractions, what's 10 minus 7 give me? Maggie? 3 over 35. And for my whole numbers, 4 minus 2? 2. Let's see how nice and easy my numbers stayed. Could I have made them improper? Yeah. In fact, in the last class, had a lot of students that kind of had worked ahead and made them improper and worked it out. And they ended up, sorry, I got to find their work. They ended up with numbers like 150 over 35 minus 77 over 35. 10 minus 7 is a lot easier than 150 minus 77, isn't it? Okay. What if, when I worked this out, it said 4 and 7/35 minus 2 and 10/35? Could I do 7 minus 10? No. So at that point, could I have made them mixed numbers if I needed to? Yes. Okay? If you're good with the borrowing technique, you can use that, okay? All right. Number 6. So number 6, again, we're adding, but you'll notice this one's already improper, so what do I want to do to the 6? Make it improper. Okay, so we're going to do 5 times 8 is 40 plus the 7, 47 over 8, plus 11 over 4. What's a good denominator for those? Malachi? 8. So my 47 over 8 isn't even going to change. Plus, what am I multiplying these by? 2. Second fraction, we're going to multiply by 2. So 11 times 2 is 22 over 8. I know we're doing this kind of quickly, but remember, this is review, hopefully. We did fractions for a long time at the beginning of the year. What do I get when I add those up? Jordan? 69 over 8. Can I leave it like that? No. So if you want to, you can go over here, do division like we did on number 4, or we can just say, how many times will 8 go into 69? Maggie?
It'll go into 8 times to get 64.
It'll go in 8 times, which is 64, so how many are left over?
5.
5 over 8. If you like seeing that division like we had up here, you can absolutely do that. All right? All right. Number 7. No mixed numbers. Yay. What's a good denominator here, Malachi? 40. Excellent. All right. So what are my new fractions going to be here? Bailey? What are my new fractions for number 7 going to be after I multiply?
15 over 40.
5 times 5 is 25 over 40. Minus? 16 over 40. Very good. All right. So I have 25 minus 16. And what do I get when I subtract that? Sasha? 9 over 40. Do I need to do anything else that fraction? No. That one we like. That one was a real short, sweet problem. All right. Number 8. Number 8. What do I need to do, Malachi?
Well, for the mixed number,
Mm-hmm.
you can make it improper. So make 2 times 2 plus 1, which is 5.
Perfect. So we make it improper, so we get 5 over 2 there. All right, now what do I need to do? Julia? Denominator is the same. What's a good denominator for 5 and 2? 10. So we're going to multiply the first fraction by 2, the second fraction by 5. All right, so what do I get when for my new fractions, Camilla? Mm-hmm. Mm-hmm. The other one as well?
25 over 10.
Perfect. 32 over 10 plus 25 over 10. So what do I get when I add that up? Michael?
37 over 10.
And can I leave it like that, Michael? How do I want to rewrite it? How many times will 10 go into 57?
2.
That would give me 20. I can go in more than that. How many times can 10 go into 57? 5. And that gives me 50, so how many do I still have left over? 7. So I get 5 and 7 tenths. Okay. All right, number 9. What's a good denominator for number 9? Layla? 6. So I only have to multiply one of the fractions. If you can get away with multiplying one fraction, it's a lot easier than multiplying 2. So I end up with 21 over 6 minus 14 over 6. And what do I get as my answer there, Harper? Seven over 6. Can I leave it like that? How am I going to rewrite it? 1 1, and 1 6. 6 will go into 7 once with 1 left over. All right. Last one. Again, it's easier to do these problems if I don't have to make mixed numbers, right? So we're going to set it up, get the common denominator without it being mixed, and then if we need to change it, we can. All right, what's a good denominator for 6 and 7? Malachi? 42. So I'm going to multiply 7 on one side, 6 on the other. All right, so my 4 stays there, and then I have 14 over 42, plus my 1 stays there, and then I get 12 over 42. So when I add that up, what am I going to get when I add those two fractions, Eli? Five and 26 over 42. All right, is that a good way to leave my answer, Juliana? Or what do I need to do still? Simplify. What can go into 26 and into 42, Juliana? 2. Guys, 2 is obvious because it ends in a 6 and a 2. They're even numbers. So let's try 2. So end up with 5. 26 divided by 2 is 13. 42 divided by 2 is 21. And that will not simplify. So 2 worked. If 2 works, use it. If it would simplify again, would I need to? Yes. All right, but 2 is a great way to make your numbers a lot smaller. All right. Guys, your homework, we just did through 10 together. On the back, it says it's numbers 11 through 30. So that's your homework. It's really 20 problems because we did 10 already together. All right. You'll notice on the back they are smaller. So you might want a piece of paper to do your work on. All right. You have the rest of the period to get that done.